So we're going to solve the following system of equations using Gaussian elimination. We're going to be using the TI-84 to do this. First thing, before you start using the TI-84, make sure all of the variables in your equation are lined up. So they already are. Here we have all the x1s in one column, all the x2s in one column, and then all the constants on the other side of the equal sign. So once you have your equation set up like this, go ahead and enter all of the coefficients and then all of the constants into a matrix. So we got to go into matrix mode, go to edit, pick a matrix, and this one is going to be a 2 by 3, so 2 rows and 3 columns. And our coefficients are 3, -1, and then the constant on this first equation was 2. And then the next equation, the coefficients are 1, 2, and then the constant was 10. Okay, and so once you do that, you can just quit and the matrix will save. And you can call up the matrix using the names screen and just hitting enter. So here's our matrix. Okay, and so now we're going to use Gaussian elimination to solve. So basically our goal is to get this first 2 by 2 section of the matrix to look like the 2 by 2 identity, and then once we do that, this column will represent our solution set. Remember that the legal rules for this method of solving equations, I can swap 2 rows of the matrix, I can multiply any row by a non-zero number, and I can also add a multiple of one row to another row. So first thing I'm going to do is I'm going to swap row 1 and row 2 so I can get this one up here into this top left corner. So the way that we do that, again, go to the matrix. Under math is where you're going to find all the matrix functions. The row swap is over here, letter C. So I'm going to swap on matrix A. I'm going to swap row 1 and row 2. So you just use commas to separate the command. Okay, and there's the rows swapped. Now what I'm going to do, so I've got this 1 in the top left corner. I want to make this 2 into a 0. So what I'm going to do is I'm going to multiply the second row by 2 and then add it to the first row, and that will get rid of that 2. So the command for doing that all in one step is over here under math again. This command right here, it's times row plus, so that's multiplying by a constant and then adding it to a different row. So the setup for this is we're going to do the number we're multiplying by first. So that's going to be 2, then a comma, and then the matrix. I'm not going to call up matrix A again because matrix A is this, and I want to do this command on the matrix that I swapped. So in order to do that, I go here and I hit second and then the minus sign to get answer. And that will call up the matrix from the previous entry and not the original matrix. Okay, so the number that you're multiplying by, the matrix, which is going to be the last matrix that we edited, and then what row you're multiplying that number by, which is row 2, and then finally the row that you're going to be adding it to, which is row 1. And so you can see it took 2 times row 2 and I added it to row 1. So now I've got a 0 here, but now I lost my 1. So what I'm going to do is I'm going to go through and multiply row 1 by 1/7. So in order to do that, you go back to your matrix, matrix operations, and over here it's times row. So that's going to multiply a row by a constant. So first you put in the constant, what I'm multiplying by is 1/7, then a comma, the matrix that you want to do this operation to, which is going to be the last matrix that I edited, so answer. And then what matrix you're multiplying, or what row you're multiplying 1/7 by, and that's row number 1. Okay, so now we've got the first 2 entries here looking like the identity. So now I'm going to make this bottom row look a little better. I'm going to use that same times row plus command. So I'm basically going to take -3 times the first row and add it to the second row so that I can get rid of this 3. So do the times row plus. And so we're multiplying by -3, so that goes first. The matrix we're going to be doing this command on is the last matrix that we use, so answer. We're multiplying -3 by row 1 and then adding it to row 2. Okay, and so we're almost there. So the last thing we have to do is turn this -1 into a positive 1. So I'm just going to multiply row 2 by -1. Although, I mean, the answer is obvious at this point, but for completeness. So let's go to matrix, and we're just going to do the times row, and we're multiplying -1 in the matrix that we just edited, and we're multiplying -1 to row 2. And there you go. So now that we've done our Gaussian elimination and we've turned this first 2 by 2 portion into the identity matrix, that means that this final column, column 3, is representative of our solution set. So the solution to the problem is x1 is equal to 2 and x2 is equal to 4.